Here we're going to look at question 8 from section 2 of the ENGAA specimen paper. So in this question we're given this circuit which has a power source which has an EMF of 20 volts and an internal resistance denoted by small r. We have an ammeter detecting the current through the circuit of 2 amps, and then we have these three resistors, So we have a 3 ohm resistor which is in series with these two parallel 10 ohm resistors. So what the question asks us to do is just to find the internal resistance, small r. If you'd like to have a go at this question yourself, then please pause the video now. Otherwise, let's have a go at doing it. Okay, so if we look at the circuit, we want to try and find our resistance, small r. Then we should try and think about which equations we should use first of all. Now, since this is a circuit equation, there's one law which we pretty much always use, and that is going to be Ohm's law, that V equals IR. So why is this going to be useful? Well, we've got a voltage up here out of 20 volts, and we're told the current through the circuit of 2 amps. So we've got these two values already for our whole circuit, but we don't have a value of the total resistance of our circuit. So if we find that, then perhaps this is going to lead us towards our value of R. Now, how to go about finding the total resistance of the circuit? You can do it a few different ways. Probably the easiest way is just to start by looking at this parallel component here. So with two resistors in parallel, there is a nice simple rule for finding the total resistance or the equivalent resistance of these two resistors together. And that is just that this total resistance, the equivalent resistance, or the reciprocal of it, is equal to the reciprocal of the two resistances of our parallel resistors added together. So substituting in our two values of 10 ohms and adding these together, we get that the reciprocal of our total resistance is equal to just 1/5, or our equivalent resistance is 5 ohms. So what this 5 ohms means is that if we were to take our parallel components and replace them with one resistor, then this single resistor would have a resistance of just 5 ohms, which I've done here. So now that we know that, we just basically have a power source with 3 resistors all in series to each other. So we can find the total resistance of our circuit, R. And it's just going to be found by adding our 3 resistances together, R plus our 3 ohms plus our 5 ohms. So the total resistance is just going to be R plus 8 ohms. So now that we know our value of R, we can look back at Ohm's law, which we know that the resistance is going to be equal to the voltage of across the circuit divided by the current through it. Now we know that this voltage is just 20 volts, and we know the current is 2 amps. So substituting these two values in, we find that our total resistance of the circuit should be 10 ohms. Now using this equation, 10 ohm, or that R equals 10 ohms is fact, and our equation that R equals small r plus 8 ohms, we find that we can say this, so 10 ohms is equal to R plus 8 ohms, which we can rearrange for R to get that the small resistance or the internal resistance of our battery is just 2 ohms. So this answer is just going to correspond with answer A given in the question.